Hello everyone. Our project title is AgroChain, Smart Farming and Crop Marketplace. This project is developed by Group G05 from Department of Computer Science and Engineering, Patil College of Engineering and Technology, Kolhapur. Team members of our group are Sarthika Suryawanshi, Kirti Ghatkamble, Saloni Sakhalkar, Pranav Salunkhe. Our project guide is Professor Kirti V sir. AgroChain is a smart digital platform designed for farmers and buyers. The system helps farmers manage farming activities and sells crop directly through an online marketplace. Now let's us begin with the project presentation outline. This slide shows the complete outline of the project presentation.
Let's start with the introduction. Agriculture is a vital sector that supports millions of livelihoods, yet many farmers still face challenges in both crop production and marketing. Limited access to accurate farming guidance, unpredictable weather patterns, and dependency on middlemen often result in reduced profits and wastage of resources. With the advancement of the digital technologies, there is an opportunity to provide farmers with integrated tools that help them to make better decisions, increase productivity, and connect directly with buyers. An all in one platform can address these issues by combining smart farming assistance with an online marketplace. AgroChain is a smart farming and online crop marketplace application developed to support farmers using digital technology. The main objective of this project is to help farmers to make better agricultural decisions and provide a direct platform for selling products to buyers. The system provides features such as crop recommendation, weather monitoring, disease detection, pesticide recommendation, and an online crop marketplace. Farmer can upload crop details and receive useful suggestions, while buyers can browse and purchase products directly from farmers. The application is developed using React Native with Expo for the front end, Firebase for authentication and database management, and Razorpay for secure payment transactions. AgroChain aims to improve productivity, reduce dependency on middlemen, and provide a user friendly digital platform for agriculture.
Let's continue with our second topic, literature survey. In this, the first topic is AgriChain. It is an application developed in 2024. It's a comprehensive digital supply chain management solution designed for farmers, traders, brokers, and logistics providers. In this, we have an application area to automate and digitize the agriculture supply chain, improving efficiency, reducing human errors, and ensuring transparent and traceables. Second, smart farming crop recommendations using machine learning with challenges and future idea. It is a paper presentation. It done in 2024. This paper presents a machine learning based module for smart farming that analyzes soil nutrients, weather data, and crop yield histories to recommend optional crops. In this, we have an application area to introduce a comprehensive machine learning driven approach for crop recommendations, addressing the challenges of data heterogeneity and promoting sustainable agriculture. Third point is advancing crop recommendation systems with supervised machine learning. It's established in 2025. The study uses supervised machine learning modules such as random forest and decision trees to enhance the accuracy of crop recommendation system. In this, we have a scope to propose an enhanced supervised learning framework for accurate crop predictions, improving productivity and profitability for farmers. It emphasizes climate-based predictions and large-scale dataset evaluations. The last one is a book as computer visions and machine learning in agriculture. It is established in 2021. It having this book discuss the fusions of computer visions and machine learning techniques for automated crop monitoring, disease detections, and yield estimations. For this, we have an application area where we can apply the AI and image processing for visual recognitions in crop, reducing manual inspections and increasing accuracy in decision making. Moving to next point, need of work. It includes direct farmer to buyer agriculture marketplace, smart area based product filtering, digital platforms for local farmers, smart farming assistance for agriculture, efficient agriculture product management systems, and simplifying local agriculture supply chain.
Next point is problem statement. To design and develop a solution for the farmers and buyers that provides smart farming guidance and an online crop marketplace using AI to recommend suitable crops based on soil type, location, and seasonal conditions, aiming to improve productivity, reduce middlemen, and ensure better market access.
Next point is objectives. First point, to provide AI based crop recommendations using soil and climate data. Second point, to develop a plant disease detection systems through image recognitions. Third point, to provide pesticides and fertilizers recommendations for better crop care. Fourth point is to develop a digital marketplace with secure payment integrations. And the last one is to provide a simple, user friendly interface for all types of farmers.
Next point is a architecture diagram. So the system architecture of AgroChain is designed using modular client server approach that integrates smart farming services with an online agricultural marketplace. The application is developed using React Native for frontend and Node.js with Express.js for backend services. Farmers and buyers interact with the mobile application through role-based authentication, and the front-end communicate with backend API to access different modules such as crop recommendation, disease detection, weather monitoring, pesticide recommendation, marketplace management, payment processing, and notification. AI and machine learning components are integrated to provide smart farming assistant based on soil, weather, and crop condition. The marketplace module farmers to upload product and buyers to approach them directly, reducing dependency on middleman. Razorpay payment gateway is integrated for secure online transaction. Weather APIs provide real-time climate updates, while the notification system keep user informed about farming activities and marketplace updates. The database store user details, product information, crop data, and transaction records securely. Overall, the architecture ensures scalability, security, efficient communication between modules, and user-friendly digital farming ecosystem.
Next point is modules. First, user authentication and user management module. This module handles secure user login and registration using Firebase authentication. Different users such as farmers, buyers, and admin can access the system according to their roles. Second, Smart Assistant module. This is the core module of the AgroChain system. It provides intelligent farming assistance to users. It again consists of modules. First, crop recommendation. The system suggests suitable crops based on soil type, weather conditions, and farm details entered by the farmer. Second, disease detection. Farmer can upload crop images and the system helps to identify possible plant diseases. Third, weather monitoring. The application fetches weather information such as temperature, humidity, and rainfall using weather API services. Fourth, pesticide recommendations. Based on crop conditions and disease analysis, the system provides suitable pesticide recommendations to the farmers. Third main module is the marketplace module. This module allows the farmers to sell agriculture products directly through the application. Buyer can browse the products, check the details, and place orders online. It helps reduce dependency on middlemen. Fourth module is the payment module. The payment module integrates Razorpay payment gateway for secure online transactions. Buyers can make payments safely within the application. The last module is the notification module. This module provides important notifications to the users regarding order updates, product activities, and farming related alerts.
Next point is software and hardware requirements. First, we have software requirements. We used a React Native with Expo to build the mobile application. For backend, we used a Node.js and Express.js. We use a VS Code as our development environment. Expo Go application is used to run the app on the mobile. We used a GitHub for a version control and code management, and JSON database is used to store a data. Now coming to hardware requirements, we need an Android mobile phone for testing the application. A laptop is required for a development. Minimum 4 GB RAM is needed. Internet connection is required. Webcam or camera is used if needed, and GPS enabled device is required for location features. These are the basic hardware and software requirements for our project.
Point is a snapshot implementation. The implemented snapshot demonstrates the successful development of major modules of AgroChain application. The onboarding screen provides an introduction to the application features, guide users through the platform. Role-based authentication screen enables secure logging and registration for farmer and buyers. The Smart Assistant module include crop recommendation, disease detection, weather monitoring, and pesticide recommendation screen that assist farmers in making informed agricultural decisions. These modules utilize AI-based logic and external API to provide accurate and real-time assistance. The marketplace snapshot showcase product listing, product browsing, and agricultural product management feature that allows direct farmer to buyer interaction. The payment gateway implementation demonstrates secure online payment integration using RezaPay for smooth and reliable transaction. These implemented snapshot or modules confirm the successful integration of front-end design, back-end functionality, API communication, and secure payment processing within AgroChain system.
Next point is future work. Integration of machine learning models and AI-based chatbot system. In future, advanced machine learning model can be fully integrated into the system for more accurate crop recommendation and disease detection. Additionally, an AI-powered chatbot can be added to assist user by answering queries related to farming, crop selection, disease treatment, and system uses. This will enhance user experience and provide instant support. Next is dedicated admin module and advanced marketplace feature. A separate and fully functional admin panel can be developed to manage user monitor marketplace activities and control system operations more efficiently instead of integrating admin features within the main application. Future improvements can include features such as a product rating, reviews, and real-time price comparison to enhance the marketplace experience. In conclusion, AgroChain is a smart farming and online crop marketplace system developed to support farmer with modern agriculture solution. The application provides features such as a crop recommendations, weather updates, disease detection, and online marketplace for buying and selling agriculture products. Firebase authentication and RoserPay payment integration ensure secure and reliable user operations. The project successfully improved accessibility, communication, and digital support for the farmers and buyer through an easy-to-use mobile application. Next is references. This slide shows the references used in project. We have included research papers related to smart farming and machine learning, along with useful websites like AgroChain and OpenWeather API for data support. We also refer to book on computer vision and smart agriculture to build a strong theoretical foundation.
We have two main folders. The first one is that the front end folder and the second one is that the back end folder. In that the front end folder, the main folders are, the first one is that the app. This is the main application folder of AgroChain and it contains the all front end screens and the navigation modules. In that the first one is that the admin module. It contains the all admin related functionality and the screens and it is used for user management, report setting and dashboard control. The next one is that the buyer module. The buyer module it handles the product browsing, carts, checkouts, and orders, and the buyer profile management. The next one is that the farmer module. The farmer module contains the farmer dashboard and the product management system. Farmer can add, edit, delete product, upload images, and the manage the stock. The next one is that the smart assistant modules. The smart assistant modules, it is the AI based farming functionality. It includes the crop recommendation, disease detection, leaf identification, and the pesticide recommendation. The next one is that the I18N. It is the multiple language supports in application. It supports the language translations such as English, Marathi for the better user accessibility. The next one is that the components. In that it contains the reusable UI components. It is the throughout the application, and it helps to maintain the consistent design and reusable interface elements. The next one is that the assets, it is stored the all images, icons and the static resources. The next one is that the services, in that it handles the API calls, externals and the internal, and it is used for the weather services, notification and the location based functionality. The next one is that the hooks, it contains the reusable custom React hooks, and it is used for the state management and the marketplace business logic. The next one is that the utils. Utils, it contains the utility function, handles the card storage, images, image handling, and the stock calculation and the reusable logic. The next one is that the constants. The constants, it is the stored the reusable constants and the application setting. It includes the backend URL, theme color, and the marketplace data. The next one is that the context. The context, it's the manage the global state using the React Context API. It is used for the role management and the language management. The next one is that the data. The data contains the local JSON files used for the testing and the temporary data storage, store the farmers and the marketplace samples data. The next one is that the types. The types, it contains the TypeScript interface and the type definition, improves the type safely and the structural data handling. The next one is that the config. In that the config contains the configuration files for integrational used for the Firebase and the future external services configuration. The second folder is AgroChain backend folder. In that, the first one is that the data is towards the all project data in GSN files. There is the user, product, notification, orders, users, etc. The next one is that the routes. The routes contains the all backend API routes. There is the login, crop, disease, images, notification, orders, payment, pesticide products, and etc. The next one is that the uploads is towards the all uploaded images and the files. The next one is that the utils, it contains the helper utility function. The next one is that the .env file, it is the secret API keys and environment variable stored. The next one is that the index.js, it is the main backend server file, and it's the start the express servers and connect to all the routes. The next one is that the package.json file, it's contain the project dependency and npm scripts. The next one is that the pesticide.js. Its pesticide name, usage details, and the disease-wise pesticides recommendation. It is in this file. The next one is that the test plant ID API files is the checks the API connection, test the disease detection responses, and etc. The next one is that the update key API.js. It is the used to update, change API keys, and it is updates the API and the manage the secure API access. And the last one is that the crops.js. It contains the crop related data or the functions. Main work is that the crop information, crop management logic, and etc.
This is the onboarding screen. Introduce the user to the application AgroChain, and it's the main feature. It's provide the information about the smart farming, crop recommendation, disease detection, pesticide recommendation, and the market access. The AgroChain supports the multilingual functionality using the English and the Marathi language, and the language icon shows the user to switch the application language for the better accessibility and the user experience for a local farmer. Then get started. Here is the role selection screens, allows the user to choose the roles as farmers and the buyer based on the role selected. I am selecting farmer, and here is the login and the registration screen. It is used for the user authentication in AgroChain. User can create the new account securely and log in as a farmer or buyer using the role based authentication. The farmer dashboard, it is the main control panel for farmer in AgroChain, and it's provide the access to smart farming module and marketplace management, product handling and the agriculture assistant features. Here is the first one, crop recommendation. It is the main features of this module to improve the agriculture productivity by recommending the most suitable crop according to the farming conditions, such as there is the soil type, loamy, clay, sandy, black and red. Temperature, it is temperature and range, it is based on there the from 0 to the 50 degrees Celsius. Rainfall is also there. Based on that, the app is suggested recommendation based on the user requirement. After the processing the environmental conditional, the backend generates the recommended crop with the relevant percentage, and the recommended the crop is displayed on the screen. The next one is that the disease detection. The disease detection, it is the main purpose of this module is detect the plant disease quickly and accurately using the image analysis, and it helps farmers to reduce the crop damages and to improve the agriculture productivity. The farmer open the disease detection module and the upload a crop image using the mobile camera or the gallery. Here I am choosing the gallery. Selected the image and it is sent back to the API to disease analysis. The plant disease detection API. The API analyzes the uploaded crop leaf image disease, and there is also going from there the pesticide recommendation. Based on there the disease, they can suggest the prevention tips and the organic alternative. The next one is that the leaf identification. Leaf identification is that the identify the which is the leaf, same as the leaf disease detection, but in this module they can suggest there the which type of the leaf and the name of the leaf. The next one is that the pesticide recommendation. As we see in there the disease detection, after the disease detection it can be switched or going toward there the pesticide recommendation, and it can be showing the recommendations and the alternative tips. The next one is that the weather update. It can be a location based, showing there the humidity, wind pressures and etc. The next one is that the marketplace and management. It is the most important in there the farmer dashboard. The first one is that the category, it is based on there the which type of the crop it is: grain, vegetable, fruits, spices, pulses, oil seeds, fibers, medicals, flowers, etc. For example, here is the grain crops, which is the grain crops or which is not. The next one is that the my crop. Here we can add the crop based on their the name, type, planting date, harvested date, areas, and it can be save the information. The next one is that the marketplace. The marketplace, it is the most important in that the farmer and the buyer section. Here can be showing the alert messages, notification. Here we can based on there the main purpose of this module, it can be reduce the middleman and create a direct connection between the farmer and buyer, and it supports the local agriculture trending and improve the product accessibility. The first here, as the farmer can add the product. Farmer enters there the crop name, price, stock quantity, vegetables, and marketplace area. And for example, here I am taking it is the vegetable, and it is the in a kg form, and add product. We can also adding the images. I am directly adding the product. The front end send the product information to the backend API and developed using the Node.js and the Express.js. And here is the CURD operation is the performing on that based on the marketplace filtering, image management, and the stock handling. And bias, this is the vegetables and the fruits according to based on the areas. The here we can adding the tomato based on the Unsgaon, as same as we can adding based on the Kolhapur city, Murshingis, and the more all options. Here are the also uh, give tell us that the 12 products, one low stock, and the 13 orders. It is all about that the farmer dashboard. The next one is that the buyer module. It is the main feature of that the AgroChain project. The module allows buyers to purchase the agricultural product directly from the buyer through a digital marketplace system, and the buyer module support the marketplace selection, product browsing, card system, checkouts, and direct farmer purchasing. After that the buyer login, here we can click on the explore marketplace. The notification is the alert message, and the notification is the giving the first. And here is the buyer first select a marketplace location such as Kolhapur, Unsgaon, Murshingis, etc. Selection helps the filter products according to the local agriculture market, and the selected marketplace location is sent to back-end APIs to fetch the related products. And it can be the API used is the products. The product I am clicking here the Kolhapur city and click on continue. Here it can be showing there the uh, all all option vegetables, fruits, and here is the latest low price, high price, and the high stock which is available, and which is the having the price low. There the all is the showing. Here I am clicking on there the latest. Here is the farmer as the test farmer market as there the Kolhapur city. The product is displayed in the modern product card, and with there the name and according whole information. The card data is stored locally using the storage. And here is when the buyer it can be added to the card. It going successfully added to there the card option. Here we can see there the brinjal, and according to available stock is the 50. According to our choice we can adding there the quantity, and go for there the placed order or there the checkouts. Here is the cash on delivery or the online payment. Here I am clicking on there the online payment, and here it is going for there the razor pay payment. It is all about there the buyer dashboard.